Alright, so let's quickly recapitulate what we have seen last time. Today is 24th. Yeah, what we have seen last time? Last time we began with K-maps, right? We have seen that we have seen a minimization technique, a graphical minimization technique in which it's kind of graph based, which was given by Karnoff. We have seen a few examples of 2 variable, 3 variable, 4 variable K-maps. We saw that the most usually, the K-map is making use of some axioms of Boolean algebra. Which are those? Yeah, can you name the property? Absorption and also distributive, isn't it? That's why we make sure that the adjacent squares vary by only 1 bit, okay, so that we can use the property. The bit or the variable which varies goes off. Okay, so we have seen the example of 3 variables, 4 variables. Let's see some more. Let's see what is called as now. See, whenever, say for example, this is the K-map. Let's consider this K-map. Or say for example, let's take the example which we have taken last time. No, hostel wala example. Or say I'm having 2 variables. Okay, take this simple example. I'm having some 2 variables 0 0 0 1 1 0 1 1, and I'm only bothered when the B bit inverts or B bit is 0 or 1. Say for example, I want the output as B bar. Okay, say for example, I want the output as B bar, so it will become 0 1 1 0, right? As this is repetitive, okay, only this many combinations would be sufficient. Say for example, my A is not changing. I am keeping A as constant to be 0. Say for example, I am having 2 inputs of a circuit and A have been grounded. Say for example, A have been grounded. So let it be A and let this be B. Now when the A is being grounded, okay, there are only 2 possibilities of B, okay, 0 or 1. Hence the output will be 0 and 1. That means it doesn't matter, okay, so as to we need not consider this input conditions, right? That means it doesn't matter whatever the values of A would be, okay, it has been already grounded. It doesn't matter what the output is here. Okay, I'm just bothered that when A is 0 and when B is 0 or 1, it should give me 0 or 1, or oh sorry, 1 or 0. I'm sorry, it's invert, no? It should give 1 or 0. Alright, 1 or 0. Okay, so I don't bother when the output is, otherwise, okay. And when A is 1 1, then output doesn't matter. So these kind of conditions are called as don't care conditions. That means sometimes it may happen that certain condition doesn't happen, or maybe some extra bits are remaining, extra combinations are there. It doesn't require those combinations. Say for example, I'm having 2 variables again. I'm only bothered when 0 0 0, okay, 1 1 0 1 1. I'm only bothered when these 2 variables are different. Say for example, these 2 variables, and then only 2 conditions I'm bothering. Okay, this output I don't care. I may have some requirement where I don't bother what would be the output otherwise. I only bother when this changes. Okay, say for example, I need to detect some change 0 to 1 or 1 to 0 and so on. It doesn't matter me when the signals remains the same 0 0 or 1 1. It matters to me when the signal changes. So at that time I would be interested in only these 2 conditions, not these 2 conditions. So those conditions are called as don't care conditions. Now these don't care conditions helps us, that means we don't care whatever the output would be. It may be 0, it may be 1, we don't care. So such don't care conditions are represented with this x, okay, in the k map or any truth table. So let's take some examples of this, and with an expression, say for example I'm having an expression as, let's take this example. So don't care conditions are those conditions where it doesn't matter what the output would be. So let's take this example. F A B C D, so it's a 4 variable k map. 1 3 7. See, when we are writing this 1 3 7 11 15, what does it mean? We must mark 1 in the k map, right, and rest as zeros. Okay, we default assume that those may be zeros, but not necessarily those may be zeros. Say for example here, okay, in the previous example, in this one, okay, the output is 1, but here it may be 0 or 1, we don't care. Okay, it's not necessarily 0, it may be 1 also. Those possibilities, here there are two possibilities, so x may be 1 or maybe 0. There are two possibilities there. So in the k map, where we were assuming that the other conditions may be 0, here we are assuming that it may not be 0, okay, unless and otherwise specified. Okay, so don't care conditions I specified with something like this: don't care as 0, 2 and 5. What does this mean? I mean 1 3 7 11 15 are definitely 1. 0 2 5 maybe 0 or maybe 1, remains will be always 0. Okay, is this understood? In earlier, what we were assuming? We were assuming that the whenever we need to place 1, okay, those will mark as 1, but whenever there are zeros, we don't mark them as zeros, we'll simply keep it blank. Okay, but some certain conditions, okay, we need to bother that whenever the x is there, okay, that means that it may be 0 or it may be 1, we don't care. That means we are just restricted ourselves to only specific outputs. Now if that is the case, can you draw the k map for that? So 4 variable k map. So let's draw the square. The procedure for simplification remains the same, with a small modification. So A B C D there, 0 0 0 1 1 1 1 0. Yeah, so it's 1 0 0, it's don't care. See here, so it's don't care, I'll write x there. 0 1 2 is again don't care, 3 is 1, 4 is nothing is given, so assume it to be 0. 5, there's a don't care, 5 is a don't care. 4 5 6, nothing is given, that means 0. Okay, that is not don't care, that is 0. 7 is 1. 8 9 10 11 is 1, right? 12 0, 13 0, 14 0, and 15 is 1. Okay, so this becomes the k map. Earlier we were assuming that where the conditions were not given, we were assuming to be 0, but here it specified that we don't care, it may be 0 or it may be 1. So at the places of x here, it may be 0 or it may be 1. Now this don't care conditions helps us in minimizing some move. Say for example this don't care condition wouldn't have been there, we would have required some extra circuit, okay, I mean some extra literals, but with the help of this don't care conditions, okay, it simplifies the circuit a lot. So let's go for it. Simplification. Let's go min term by min. What is the procedure? Go min term by min term. See what are the adjacent ones with which this min terms can be combined. So consider this one, 0 0 0 1 wala 1. So this can be combined with this one. Is that the unique way to combine? So that's the one way to combine. We can also combine this one with x. Why? Because x may be 0 or 1, we don't care. Assuming, now see, when I am saying that x may be 0 or 1, it's our prerogative to set it as 1 or 0. Okay, so let me write that. So x may be 1 or 0. What to set depends on us. Again, it depends on the designer. Like I need to simplify. I mean, so depends on, or let me write in other words. So we can set, can be set as per the simplification required. You got it? See, here its x is there. So as a designer, I have to be intelligent to set this x. Say for example, it is 0, 0 there, and this all x are 0. So there may be only one possibility of this one to be combined here, right? So there may be only this possibility. But here, how many variables are there? I mean, what is the expression here? A bar, B bar, C bar, and D. So there are 4 literals here. But being an intelligent designer, I may set this x, or we don't care about that output. Okay, assume that the output is 1 there. Assume if I assume that output is 1 here. Okay, if I assume x to be 1, then I would be able to combine all 4 of them, and hence the literals would be reduced. What would be literals here? A bar and B bar. Okay, so can you see the difference? So we can mark x in our way. Okay, it's our prerogative to set x as 0 or 1, just because we don't care. Okay, certain output conditions we don't care. It may be 0 or it may be 1, because as a designer, as a specific, as a client, what I would do it. See, सिर्फ मेरे को output ना इस वक्त मुझे 1 चाहिए या फिर इस वक्त मुझे 0 चाहिए. बाकी वक्त मुझे क्या होता है मुझे नहीं पता. In a big chemical plant, or in, say for example, I'm having a chemical plant. I'm saying that okay, there are some some 4 variables there. There are 16 such conditions. I will only say that only if B and C are 0 and 1, okay, then only you set the output. Then only you turn on some light or turn off some light, or you just give an indication. Rest doesn't matter. That is, those conditions are known as don't care conditions. Okay, so that we may assume at 0 or 1. All right. So having said that, here as an intelligent designer, what I would do is I would set this x as 1s, isn't it? That means I can combine this x with 1s or 0s depending on our simplification required. Okay, so it would be intelligent to combine this. Okay, to combine it. Now simplification process goes the same way. Check for this. Is it the only possibility of this to get combined with this? No, this is one possibility. Okay, let me. This is one possibility, and another possibility is I can combine one with this. I can combine one with this. Okay, because x can be anything. Same thing with the others. Okay. Now let's go for 4 possibilities. Can you tell me, is this the only possibility where we can combine it in 4 ways? So there is another possibility we can combine. Okay. What about this? Same thing. Okay, so I can either we can go for this way or that way. What about this one? Only one possibility is here. Let's combine that. So what is the variable here? B bar, C, D. Okay, only one. Now you need to continue with this procedure until all the 1s are covered. Okay, we don't care about x, we don't care about 0. Only until 1s are covered. We can take help of x or don't care conditions only when it is required. जरूरत नहीं हो तो उसको condition नहीं करना है. Otherwise your expression will be a big one. Next one. Consider this. Is that the only way to combine this 4 ways? No. There are 2 possibilities here. Okay. So there will be 2 such possible expressions. Either we can combine like this, or we can combine like that. Isn't it? See how many variables are there, like this or like that. 4 variables are there. Anyway, 2 minterms will be reduced. So there are 2 possibilities here. Okay. So the expression would be B bar, C, D, or yeah. Oh, sorry. So only CD. Only CD is there. Yeah. I'm sorry for that. Yeah, so B is all, I didn't consider all. So A and B both are varying, so only CD, right? You're correct. Okay, plus what is the other one? Okay, I can combine. So if I consider this red one, okay, the possibility would be A bar, bolo, D, okay, and the other possibility would be CD or the green one, A bar B bar. Okay, so this is one possibility, that is another possibility. Both are having the same number of, both is having the same cost. Okay, so there are two possibilities here. Now okay, all right. So it may sometimes be beneficial to go for this one. Why? Because there is less inversion required here. I mean, D doesn't require any kind of inversion here. Here both the variables need inversion. So I may choose this one. So it's up to the designer to choose. Is it okay? Now consider this example. Let's go for the another example. Quick, go for this F A B C D. Now I am giving in POS form 4, 5, 6, 7, 8, 12. Now see here, see how I am expressing this. Okay, here it was plus, this is in POS form, so it should be here. Yes, don't care. I don't care when the output is 1, 2, 3, 9, 11 and 14, let's say. Alright. So here you should see, you should always remember that whenever this product sign is there, you should mark zeros. Okay, the X indicates, we may take X as zeros whenever the simplification is required, and so on. Solve this. Can you solve it by you? Should I go ahead? Solve it by yourself. Yeah, tell me the expression. First, form the K-map properly. There are 4 variables there. You must mark what? Zeros, right? Whenever the expression is A, B, C, D, don't care here, don't care, zeros, don't care, don't care, sorry. This is okay, K-map. Tell me the expression, final expression. Now see here, now we need to combine zeros, okay? See here the unique way in which it can be combined with 2 zeros. So this is not unique, okay? I mean each of them are having at least 2 possibilities. Go for group of 4, go for group of 4. Consider this one. How many possibilities of grouping it as a 4? 2 possibilities. This is one possibility, there is another possibility. If we consider this X to be 0, okay, as I said, this X can be 0 or 1 depending on our requirement. Okay, now what about this one? How many possibilities? two possibilities again. What about this? Again two possibilities. What about this? No, I mean four possibilities are not possible here, right? So yeah, this one. Sorry, one possibility only. One possibility is there. Okay, only one possibility. Mark it. The rest I can combine. Wow. Now see, this is one possibility like this or like that. So anyone is fine. Okay, so I can go for this or I can go like that. Anything is fine. We don't need to now. Once this is done, okay, I don't need to now. Okay, this zero is also remaining, right? So I need to combine it to largest possibility like that. So note down the expression, you get the final expression. Okay, now see here, let's take this example and alright, you got this, right? You can write the expressions. Let's go ahead. Let's go for 5 variable k, man. I'll give you some homework, some more homework. Try to solve this example f w x y z. Always remember that all the ones or zeros must be covered and the expression must have as minimum cost as possible. That's it. Take this as a homework. Is it okay? Okay, let's go ahead. 5 variable key man. Now take this expression f a b c d e and alright, sum as 0 2 4 6 9 13 21 23 25. I'm taking some standard examples. 29 31. Don't care conditions are not given, that means rest of them are zeros. Okay, now there are 5 variables, right? Now 5 variables के लिए I'll have to go for 3D. Okay, there is one more. 4 variables we could easily form the squares, but for 5 variables, instead of complicating the things, what we will do is we will draw a 3D picture, okay, of this. Now this is not the only way, again I am saying, okay, you can go by your way. Those who are not comfortable with 3D, you can go for 2D also, no problem. See why I am using this 3D picture just because it's very easy to understand the overlapping procedure. Just because you see here, this first square indicates this. See, whenever there are 5 variables, just pay attention here. Whenever there are 5 variables, how many possibilities are there? To the power 5, isn't it? So 32 such possibilities. For 32 such possibilities, you may see that the A is having only 2 possibilities, either 1 or 0. For A to be 0, there are 16 possibilities for BCDE, and A to be 1, there are again 16 possibilities of BCDE. So we have splitted this A variable into 2 K maps. Okay, so A variable, so here A is, for upper one A is 0, and for the lower one A is 1. Remains are BCD. So BCD is having 4 possibilities. BCD, 4 possibilities are as usual, right? I'll draw the K map like this. We'll go by the usual way: 0 0 0 1 1 1 1 0 and so on. Now, can you tell me the numbers here? A is 0, right? So 0 0 0 0 from you can start the numbering from here, right? So 0 2 4 6 9, all these are ones, right? So let's go by that. Now we can cover until 15, right? We can cover until 15. Let me remove this background. Yeah. So 0 0 is 1 here. Let me mark it as 1. 0 1 2 3 4 is here. 5 6 is here. 7 8 9 is here. 10 11 is not there, right? So let me erase this. Yeah. Are you getting this thing? Okay. Now here again the same procedure. Okay. So 8 7 8 9 10 11 is gone. Okay, 11, then 12 13 has to be 1, 13 14 and 15. That's all. Okay, till 15 it's covered. After 15, come to the next map. Same 0 0 0 1 1 1 1 0 and so on. Mark once. Now here the beginning starts from what is the number? 16, right? 16 is here, right? 16 17 18 19 20 21 is here. 22 23 24 25 26 27 28 29 30 and 31, like that. Is that okay? समझ गए? ठीक है. I have splitted this. If you see the combinations, okay, see what I am saying is A B C D E 5 variables है. इनमें से for 8 to be zeros, okay, these are having 16 possibilities from 0 0 0 0 to 1 1 1 1. Again for A equal to 1, again there are 16 such possibilities from 0 0 0 0 to 1 1 1 1, isn't it? If you see the bit pattern. So I am splitting here A into 2 K maps, zeros and ones. Okay, so one K map of 4 variable for A equal to 0, another K map of 4 variable for A equal to 1, and so on. Okay. Now how to combine? Now pay attention here. How to combine? When you are taking into consideration the adjacency, okay, you need to take care, in between these K maps also, in between these 2 K maps. So let's go minterm by minterm. Say for example, first one, let's consider this. Which one? This one. Let's go minterm by minterm. How many possibilities of adjacency of group of 2's are there? There is one possibility like this, another possibility is this one and that one. Okay, that's not unique. Go for the next minterm. Same is true with this, same is true with this, and with that. All 4 are gone. Consider this. How many possibilities are there? 1 possibilities and 2 possibilities. Okay, see the overlap. ये और ये वाला. See here, ये वाला और ये वाला. Okay, one possibility is like this. Next possibility is in between these K maps. Okay, come to this one. One possibility like this, another possibility is like that, isn't it? Now go for this one. Again two possibilities. Here again two possibilities. Come to this. Again two possibilities, and so on. Go for a group of 4. Go for a group of 4. This one. 4 possibilities hai kya? How many possibilities? Only one. Go for this. ये tell me the expression. See, पहले देख लो, बाद में समझ के फिर कर सकते हो. यहाँ पे एक्सप्रेशन क्या होगा? ए बार, ये ए बार है यहाँ पे, ठीक है? ए बार, अभी बार की कंसिडर करो. यहाँ पे कॉमन कौन से हैं? बी बार, उसके बाद ई बार. See, four group of 4 ones, 2 variables are gone. Always remember this. It's a recheck. Okay. And then these 4 ones are covered. Leave the rest. Go for another group of 4s. Okay. All right. So consider this one. How many possibilities of group of 4 is there? See, these two can be combined with these two also. See between the gaps, between the maps. Okay, how to prove that? Let me mark this first. So this one and that one forms one group. Okay, now see which variables remains constant. Okay, now you don't need to see these two variables are common here, so you don't need to see both of this map for BC. Okay, you can consider either of this map only to see the variable change for BC. How many variables are remaining constant here? Only B is remaining constant. Okay, so B is remaining constant. B, then see here D bar and E, isn't it? D bar, and E. Okay, two variables which have gone. Okay, group of 4 means 2 are diminished. Okay, 2 are gone. Okay, yeah. C, which C is changing, right? 1 0 is changing. No? C is changing 1 from 1 to 0. Here also it remains constant. No? See here 1 0 is changing. Here also C is 1 0 is changing. C is anyway changing. In between these, when you are considering this, A is changing. So A has gone and what? C has gone, isn't it? When you take a group of 4, A is gone and C is gone, but B remains constant for all 4 of them. Consider a group of 4. Is it okay? किन लोगों को समझ में नहीं आया ये? Okay. All right. So this is done. Then this. All right. Now go for this one. Okay. Delay. Yeah. Go for this one. How many possibilities of group of 4 is there? Only one possibility. Mark it. So this one. Can you tell me the expression? Oh, that's easy. A is there. Okay. Then C. Then very good. C is there. C is remaining constant and E. Alright. समझ गया? So final expression becomes बोलो B D bar E or ACE, okay, or बोलो A bar B bar E bar. All right. Take this example as a homework. You can do by yourself. Oh, you can do by here or you can take it as a homework. No problem. So example. Now this is more challenging. ठीक है. F equals If I give don't care condition, it becomes slightly more complicated, so I'll try to avoid that, but I may be cruel to insert don't care conditions also in the exam, so do as much practice as possible. 0, 5, 6, 8, 9, 10, 11, 16, 20, 24, 25, 26. More number of ones, more complication. 27, 29. Sometimes it may give advantage also. Solid. Okay. Now I just need to tell you that there are some very good apps which are available, okay, on your mobile phone. I think for one batch I have already said. For on Play Store you can go for this KMap map, okay, or else it's available on the website. Those who didn't check the website, for those, okay, till it loads, go back to the this is a nice app, KMap solution, okay. So tell me the previous वाला 4 वेरिएबल का के मैप बोलो जहाँ पे जीरोस थे. जीरोस कहाँ पे थे बोलो. Zeros या फिर ones. Okay, take any example. We have taken this don't care वाला conditions, no? See here. For don't care you press it twice. Then it was 1 here, 1 there. It was don't care there, and then don't care here, 1, 1, 1 and 1. Okay, so is this solution right? See here, है ना, एक में ऐसा कंबाइन कर सकते हो या फिर वैसे भी कंबाइन कर सकता था. So there are two possibilities here. Two possibilities are also given. Okay, so this is a nice app using which you can verify. Okay, not only this, if you scroll this, okay, if you slide this, or not this, sorry, you can see the check circuit or truth table here. If you click truth table, you'll see the mappings, okay, how many variables are mapped in which circles. If you see check circuit, it will give the possible circuits also, the usual way of combining the circuits, then using only common inverted circuit, using only NAND gate, using only NOR gate, and so on. Okay, you can use this app and verify yours. Okay, it can solve up to 5 variables. So the 5 variables you can simply get by scrolling, by sliding this. Okay, 5 variables. Now here 3D नहीं है, 2D है, तो 2D भी आप बना सकते हो. Okay, those who are not comfortable with 3D, you can prepare 2D graph also. How 2D graphs are there? See here. Here A is changing, A bar and A is there. That means A is 0 here, A is 1 there, and we have simply considered 4 variable K-map. You just need to remember that. Okay, the overlap should be considered between the maps also. Okay, all right. So let's go ahead. Now the 5 variable K-map is done. Now take some examples. Say for example, take this example. Say you need to detect odd number of ones. In 3 variable or 3 bits. Variation. Okay, so you need to detect odd number of ones in 3-bit variation. So prepare a truth table for that. Prepare a truth table for that. Let the variables will be A, B, C. Odd number of ones के लिए detect करेंगे. So write all the possibilities. So very first step is to form a truth table. Okay. Okay, odd number of ones बोलो 1 1 0 1 0 1. Alright, make a truth table. Okay, solve it using K-map and realize the circuit. Can you do that quickly? Do it. form a K-map out of this. You will get a K-map like this. Okay, do that quick. Need to cover a lot of things today. A, B, C. बोलो 0 1 1 0 0 1 1 0 उसके बाद ओके एक फिर से खा गया क्या मैं? ऐसा क्यों होता है? कौन सा मिसिंग है? 1 0 0 अच्छा ये वाला मिसिंग है ना 0 oh I'm sorry 1 1 1 is 1 okay so it becomes 1 0 0 1 so 1 0 0 is it okay huh what to huh is it okay? It's okay I think yeah it's fine go for K-map see here go with the same procedure apply the same procedure for K-map now see go for very first step is what find isolated ones how many isolated ones are there check for this how many possibilities is this isolated yes it's an isolated one it can't be combined with any other ones okay either fashion so it's an isolated one similar this is also isolated that is also isolated and so on okay form a minimized expression for this so what is the expression you tell me A B bar C bar or A bar B bar C or बोलो A B C or A bar B C bar okay so observe first observe then write so this is the expression F so see K-map minimization के लिए use हो रहा है पर you know with the K-map with the basic gates and or and not this is what the minimized expression is okay but if you are using other gates okay K-map will give only the minimization with respect to and or and not gates if you need to minimize it further you need to take help of other logic functions we have said that the 2 to the power 2n combinations are there for all logic possibilities okay we may have to take help of other logic functions also say for example I may take this B bar common from here yeah so what would the possibilities here B bar is if it is common then it would be A C bar or A bar C if I take here next two what can be common B A C and A bar C bar right is it okay this can be considered as now A C bar plus A bar C go to the bookmark page पे जाओ देखो ऐसा कौन सा एक्सप्रेशन है हाँ क्यों कौन सा एक्सप्रेशन ऐसा एक वेरिएबल चेंज हो रहा है दूसरे में दूसरा वेरिएबल चेंज हो रहा है ऐसा कौन सा एक्सप्रेशन है देखो गो टू द बुकमार्क पेज क्विक जल्दी फटाफट बोलो ओके सी वेयर ऑल द combinations I have given 2 to the power 2n combinations जहाँ पे मैंने 16 possibilities लिखी गई थी वो कहाँ पे yeah what is called that x or right A C bar plus A bar C it's written as exclusive or okay that means exclusively if it is or function that means it's odd number of ones are there then only it will be 1 okay so that function I can write now there is a way to represent that so I can write like this plus and a circle to that okay this is called as XOR function and can I write now this you tell me about this XNOR I have written that so this can be written as XOR का inversion no XOR का inversion okay XOR का inversion है you can verify that okay A C bar और A bar C इनका अगर मैं नॉट लेता हूं तो यू अप्लाई डी मॉर्गन्स थ्योरम ओके यू विल गेट दिस काइंड ऑफ थिंग ओके XOR का inversion is XNOR, so it is like this. Or see, there are two ways to represent this. See here, पहले देख लो, okay, बाद में लिखो, okay, लिखना important नहीं, ये available रहेगा नेट पे. X, whenever there is X, एक वेरिएबल चेंज हो रहा है, A C bar और A bar C, it is represented as XOR function. XOR can be represented with like this, okay. If it is A C and or A bar C bar, this can be represented as like this, dot and circle to that, or no, इसका inversion, okay. So there are two ways to represent that. C का inversion. I mean, it's one and the same thing. If I need to express it in more compact form, I'll write like that. But the meaning of that is only this only. Okay? All right. So yeah, what would do minimize expression here? Here. अब देखो यहाँ पे देखो पहले ध्यान दो, यहाँ पे ध्यान दो. एक वेरिएबल चेंज हो रहा है, दूसरे वक्त कांस्टेंट रह रहा है. ये यहाँ पे ये कांस्टेंट है और ये vary हो रहा है. I mean, the term in the bracket is constant here. Here it's bar of that. Here it's bar of B. Here it's B bar. So it will be XOR of this bracket and B, isn't it? That means XOR of A XOR C. This is one variable XOR उसका B के साथ. Now as it is distributive and associative, okay, I can simply write as A XOR B XOR C. So this can be now with AND, OR and NOT gate, okay, we may need this variable, but if you have XOR gate, okay, slightly more complicated gate, okay, we can use only two XOR gates to represent that. So that can be written like this, okay, that can be realized like this. So XOR is expressed like this, okay. Symbol is this for OR. XOR we are having one more, शेंडी रहेगा इसको. देखो यहाँ पे A और दूसरा XOR, सॉरी इसका आउटपुट ना, ये XOR ऐसे और isn't it? So A, B and C, that's it. So output is A XOR B का XOR BC का XOR और फिर A, everything is the same. A B को अभी मैंने अगर कंबाइन किया फिर भी एक ही आपको मिलेगा. I mean I can write here A C and B. Okay, that's one and the same thing. Yeah, just because they are associated. So I may write A, C and B. Is that okay? Oh, okay. So all right. So I'm assuming that the XOR gates which is available is 2 input XOR gate. Usually that is the case. There are some ICs, okay, which can provide 3 input logic also. So we can go for n input logic, but what are commercially available are 2 and 3 input. Okay, if you need to create, let's say 3 input XOR gate, this is one kind of way wherein you can create a 3 input XOR gate using 2 input XOR gates. Is that okay? Okay. Yeah, so yeah, close. So that was my next thing. So this kind of pattern, the odd number of ones are having pattern. Okay, this kind of pattern is available in what is called as a binary adder. Okay, we'll consider that quickly. Let's do that. So in binary adder, okay, we have 2 bits, right? A, B. Now always remember, whenever we need to realize arithmetic addition, binary arithmetic addition using logical operations, right? So here, whenever we are considering addition operation, there is sum and a carry. So how many possibilities of A and B is there? 0, 1, 1, 0 and 1, 1. What is the 0 and 0, plus 0? You tell me. Now arithmetic, we need to implement arithmetic wala na. 0, 0, sum, carry is 0, 1, 1, carry 0. Carry here 1, 1 is 0 and with a carry 1. Okay. So see here, again it's a kind of odd detector. Sum operation here is a kind of odd detector, isn't it? Sum operation here is a kind of odd detector. So here you will have to form 2 K maps. because देखो मैंने बोला था कि circuit or my specifications may not have a single output. I may have some complicated circuit wherein there may be two outputs. This is one example of that. For 2-bit addition, I may require two outputs. One is sum and one is carry. So as to feed it to the next bit. Okay. So here you will require two K-maps. One for the sum and another for the carry. So the total number of K-maps is total number of output pins required. Okay. So here you'll find it for sum and for the carry. For sum you'll get the same pattern. Okay. So I mean it's a two variable, right? So it's a two variable K-map. So it will be 4 squares A B, simple one, 0 1 0 1. Okay, mark 1 0 0 1 1 0 and so on, isn't it? So if you go for K-map, we will again get A XOR. How? Mark this. What is the possibility? A B bar, and this is A bar. So this is sum, right? Alright. So this kind of operation, odd number of ones, is there in XOR combination. What about sum? Or what about carry one? What about carry? So A B 0 1 0 1, C is 1 only for here. Okay. So what is the expression here? A B. Only with AND gate and one XOR gate you can implement 2-bit addition. Okay. So realization would be XOR, which will take two inputs A B, so that will give you sum, and same two inputs if you give it to AND gate, you will get carry. So this is the circuit, okay, which is inside your 2-bit adder. Two inputs, two outputs. I'm seeing some blank faces. Yeah. Anything you haven't understood there? You didn't understand what? Alright. So these are 4 possibilities of 2-bit. Okay. We need to go for 2-bit addition. Whose lecture is there after this? So one. Okay. Fine. 2 bits are there. 4 possibilities. You'll get 2 outputs. Binary addition में 2 होते हैं outputs. Sum and the carry, right? So we have simply represented those 0 0 0 1 1 0 1 1 sums and carries. Now for each output there will be one K-map. Okay, one realization for each output, right? I need to implement a circuit. It's not like I need to implement it for sum, I need to implement it for carry also. So I have simply represented with the K-map for sum and K-map for carry. Okay, I have simply inserted that one. I found that the expression turned out to be A XOR B. For carry there is only one for A and B equal to 1 1. So I have got expression as AB. So that means what? If 2 inputs are there, I can realize it using 2 gates, which are not standard gates, but okay, XOR and one AND gate से मैं realize कर सकता हूँ. So this is what is inside a 2-bit adder. Now this kind of circuit is specifically called a half adder. Half adder, 2-bit half adder, or a half adder simply you can say. Let's say half adder. Then obvious question is, what is full adder? See, for example, if I'm adding some 2 bits, let's say the bits are 1 0 1 0. If I'm adding those, okay, so 0 0 is 0, 1 1 is 0 and a carry there, right? But here on the LSB there is no carry, it was generated. Say for example it is 0 1 and, or let's say 1 1 and 0 1. Say for example you take this condition. For LSB 1 1 is 0 and with a carry. Here it is again 1 1 is 0 again with the carry. So for each bit there is a carry generated which has passed on to the next one. Okay, but for this one, okay, but for this carry it has received the carry from the earlier one and again it has generated a carry. That means what? At the input also you will require one more extra bit which is coming from the previous bit, right? So there is a carry which has been generated from the previous bit. So homework for you is to form a circuit of a full ladder. So let me write that. Full ladder. Okay, but you can't with two half adders you may not be able to. हाँ okay, two half adders पे भी हो सकता है. Okay, but ठीक है, two half adders से I may not say, you just need to realize a full adder circuit. Okay, in the full adder I want 3 inputs, so A, B and C n minus 1. So that is the carry from the previous stage. If it is the first stage, I mean LSB अगर है, I mean if this full adder, if I am implementing for the lowest bit, of course this carry has to be 0, okay, because there is nothing coming previous to that, okay, and the output will be 2, that is sum and the carry of that stage, okay, that is full adder. See, what I am saying is, if 1 1 and 0 1, so they are 2-bit addition, right? So this is LSB and MSB. If you need to implement this with full adder, okay, this circuit का previous कोई carry है क्या? नहीं है, तो इसका मतलब ये C n-1 here it should be 0. For here it would be, you know, whatever the carry has been generated from the previous stage, that means C n-1. Okay, it may be 1 or it may be 0, depends what is there. Okay, so homework for you is to realize this and okay, so you realize this. Okay, so is it okay? अभी तक कुछ प्रॉब्लम कुछ समझ में नहीं आया? Cost is always how many inputs are there, how many gates you are using. Okay, but I'll specify. You have to be careful here. If I am asking you to calculate a cost in terms of standard gates, okay, then it may be higher as compared to the non-standard gates. That means non-universal gates. Let's say मैंने यहाँ पे XOR, take the previous example. यहाँ पे कॉस्ट कितना है? 2 गेट्स और कितना है? 2 गेट्स, you know, 2 inputs for each one, right? So it becomes 4. What is the cost if we have used only AND, OR and NOT? See here, I mean 3 input for, you know, each of these 4 combinations, right? So that means 12. And how many AND gates are required? 4 AND gates and 3 OR gates, isn't it? So 12 plus 4 plus 3, I mean that is, the cost is higher. So cost, whenever you are specifying, you must specify that using standard gates, okay, I mean normally, okay, I mean standard gates in the sense, now this is not standard again, okay, this is not universal implementation. AND, OR and NOT are not universal gates. Universal gates are NAND and NOR. So you need to convert this to NAND and NOR expression, NAND only realization and NOR only realization, then calculate the cost. Are you saying? Whenever, unless and otherwise specified, whenever you I'm asking you to calculate the cost, you should specify it either in NAND combination, all the minterms in NAND combination or non combination with respect to universal gates. Is that okay? You got it? Now it should be very clear. I mean NAND and NOR only, no confusion. So let's stop. Any other